So, my name is Sean Larkin, and of course, the title of this talk is called Webpack 4.0, the most important update for Angular. You might be like, what is he talking about? So yes, like I said, my name is Sean. I'm a program manager at Microsoft for the Microsoft Web Platform team. I specialize as a program manager on Edge Dev Tools, helping to make Edge Dev Tools the best developer tools for Windows and the modern web. And I'm also a maintainer of an open source project called Webpack. How many here use Webpack? It's okay if not. So, okay, all right. How many here have heard of Webpack? Okay. How many understand how it works? You don't have to be shy, okay. That's okay, it happens. So, you get to use it by default anyway. Who uses the Angular CLI? Can we give a round of applause for how much hard work that they do to take off some of the hard work that is involved in doing things like bundling compilation? It's been probably one of my favorite partnerships, working not only on Webpack, but I started out on the Angular team and working on the Angular CLI. But also just an evangelist for general open source sustainability. So a little bit about myself, I'm a tech support rep gone rogue. I got tired of not being able to solve people's problems. And so I started to learn how to program. I started with AppleScript. And then whoever written AppleScript? Like, that was so cool to me back in the day. I got to automate things. And then I learned Ruby, and then finally Objective-C, and then JavaScript. Kind of a crazy path. But like I said, one of the most important things to me now, besides maintaining Webpack, is also ensuring that other projects like Webpack can thrive. And so, how to get contributors, how to be a first-time contributor, not only to our project, but to projects like Babel, Angular, React, Vue, that depend on the quality contributions from others. And so you can find me at the Larkin, so like at any of those places you see there, or it might show up, we'll see. And if you're on Twitter, you can literally just be like, you can write that right now, I'll give you a chance. Go ahead, take your time. I need it now. Okay, so yes, like I said, Webpack 4.0, and this is kind of a weird title. Like, how is this the most important update for Angular? Well, to us, we feel like it's really significant for the Angular community. And so what does this really mean? And so I wanted to boil down kind of 3 pieces of what kind of this release meant. This whole talk is really to just get you excited about what features we're adding to Webpack 4, and then how you can get involved or test it and use it for the first time. So, I kind of broke it up into 3 pieces, and they're kind of high level. So the first one is, let's see if I get the slide there, is build and size performance. And they're kind of 2 separate things, but I kind of grouped it together. I like the 3 circle instead. Modernization. So, dropping old JavaScript practices and replacing them with new ones, the new architecture. And then defining what it means to have a good developer experience today in 2018 and how it relates to you. And so, the first one was actually really interesting. Smaller and faster builds. So if you think about it, you can't really, your program can't be more performant, because to do that, you're really having to install a new chip in your computer, and it can run in a higher optimized machine, Instead, what you need to be doing to have a faster build, you have to do less work. And so, or reuse work that's already done. But to have smaller builds as a compiler or a bundler, you have to do deeper analysis of your code, and you have to process more of the module graph. So there's kind of these are kind of conflicting here. And so maybe I'll try and connect the dots on how we accomplish both. And so without getting too crazy into detail, just a higher overview is that we completely rewrote our chunk graph. And I'll have a special surprise graphic to show you about that later. But who here, knows what Uglify.js is? Who here has struggled with it having to not be able to compile to ES6? Well, yeah, I know those hands over there. That's me too. So we're now shipping with it out of the box with ES6 support and with parallel processing and full caching. So every subsequent production build should be faster. And then we moved from all of these older data types that are harder to analyze and not as optimized for the JavaScript engine, like objects and arrays, in our code base, and we replaced them with things in ES6 like maps and sets. And then we completely rewrote our plugin system. So from the ground up, you'll notice that if you're trying to write a Webpack plugin for the first time, it's going to be considerably easier. And because we're going to be able to ship typing with it and a set of type files from Definitely Typed. They're now monomorphic, and who knows what monomorphic means? Maybe? Okay. So essentially, when you hook up into an event system, what we're doing with Webpack is we're going to compile down this hook based on how many things are plugged into it. And so that's going to ensure that we only return one type of data, and it's predictable for JavaScript engines to optimize for. And so 97.778, that's a magic number right there. What does it mean? That is the upper bound of build time reduction, specific to Angular applications. 98%. 98%. Now, in this use case, and I think I even will share, yes, there we go. We were seeing a build. Now, it says here 6 hours. It actually went 9 hours. But we were able to reduce it. And you can take a look at, from that link if you want resources. But even before we released our beta, we were bringing it down to 17 minutes. So I don't want to get too much into detail yet because it's kind of a surprise, but this is part of the chunk graph refactoring. And then you're like, Sean, that seems like a pretty unrealistic number here. But we've been actually surprised to see that the average is 75%. So this is not just Angular builds. We're talking about React, Vue, just vanilla JavaScript. So 98%, 75%. These are things that are really exciting to me. And I want to be proven wrong so that we can see otherwise. But this is the first step. And then also, she'd be like, okay, Sean, what about these build sizes? So I want to give you a little explanation of how ECMAScript modules work, or what kind of a specific detail in the spec. So if you see this code right here, we have this, let's just pretend it's a library. It's in your code locally. And you export 3 different modules exports into you're exporting it from this file. So then this way, it's kind of like, do we still use the term barrel exports? Stephen? No, is that not a thing? Do you remember what barrel exports were kind of early in Angular 2? This is kind of this technique where you're exporting a bunch of files to make it easier to import everything you need from a single location. Who here knows this technique or has used it before? Okay, sounds great. Did you know that the ECMAScript spec says every export here that's re-exported has to be evaluated, parsed, and executed in case that there might be, if A modified B before it was exported, or if B modified C, so what we call side effects. So in that case, in Webpack 3, we stay compliant to all implementations to spec first. So you might have seen all of these things included in your code by default, and impossible to minify. Because we don't want to break existing libraries like RxJS or D3, 3JS, which do rely on side effects when they're exporting modules. However, you need to have a way to signal to the compiler, hey, you don't have to worry about side effects here. So what we added was a feature called sideEffects, or basically a property that you can add, or a library maintainer can add in their package.json called sideEffects false. And all this does is say, Webpack, go ahead and prune those exports out that are unused. They are not going to cause any side effects when you build them. So like I say, it allows you as a user to specify compiler hints to Webpack and safely prune side effects. And so who uses Lodash or has used Lodash? So John, JD is a coworker of mine, working on Chakra and on Edge, but also Lodash. And he's been helping me test this and dogfood it since we implemented the feature. Now you see that he calls it pure module, which we originally named it. But so essentially this allowed, I always talk about JavaScript in the uncompressed size because that's the cost to the browser that's always incurred. So we're talking about a library bundle that was 223 kilobytes reduced to 3. So I should have put the flashy percentage, but I didn't. So if you really want to perform an application in Webpack, all you have to do is tree shake, mangle export, scope hoist, minimize, and then package authors have to set their side effects. Sound easy? Right? No, it's not easy. That's ridiculous. We're in 2018 now. We want to give you smaller builds, and we want to provide you a better way to do it just by running Webpack. It's funny because it sounds pragmatic, right? Well, guess what? Out of the box in Webpack 4, it does everything that is just mentioned right there. So you don't have to do any of that. We're going to take care of it for you. You're welcome. But no, it's okay. But seriously, this is what developer experience means. Now that we have these features stable and proven, vetted through teams like Angular and Vue and React, we now have the confidence that we can make defaults. Thanks to other toolings that started giving you the opportunity to try this without a configuration, we now have the validation to say, this is what people want, so let's do it. So as you can see here, this is literally an entire build that's optimized to 583 bytes. It's a tiny example, but you may see something missing there. So when I say you can run with Webpack, that means you don't even need a Webpack configuration. Right there. We are defaulting the entry point, the output, the production environment by default. When you run it, it's just going to happen. So we want to make it foolproof for you, even if you don't understand or care how bundlers work. And so it means a lower barrier to entry. It's sensible, sane defaults that I think people who don't care about bundlers expect. And then it's also something that we specifically at Webpack coined called 0CJS. Who's heard of 0CJS? Maybe if you follow me on Twitter. So it stands for Zero Config JS. If you ever see a new tool in the next 3 weeks, you'll see maybe 10. They might all literally say zero configuration on it. But we call it 0CJS because it means something a little different. You might hear somebody say zero config means letting you do anything you want without ever touching a configuration file. Wrong. How does that make sense? That's a flawed architecture. You're basically forcing every single user possibility. Who here uses the exact same stack? If you do, raise your hand. And the same integrations. So why would you try to force that into one expected user case? You're not going to. And as you might see, if you're following other projects, it comes with riddled architecture behind it too. And so we believe that zero CJS means that you're extending the ability for your ecosystem to provide a zero config experience. You should be able to define your own conventions and share them. Angular should be able to provide their own conventions and share them. And so by Webpack having the defaults that we do now, when we implement our preset system, we're basically saying, now you can extend that zero configuration for everybody else that has the same kind of project guidelines or has the same kind of needs, without trying to muddle a bunch of requirements into our, what Webpack does best, which is compile, bundle, code split, scope hoist, and tree shake. And I mean, like I said, like presets. If you don't know, I stream live on Twitch. I guess in France time, it's every morning on Wednesday and Saturday, or Wednesday and Friday mornings. I'm streaming on Twitch, open source Webpack. And this episode here that I have linked, I literally implemented probably one of the most, the trivial preset systems. But as you can see here, what if this now means that we could do something like this, where we could have packages that automatically load and set your defaults for you. So here in this, I think in this episode, I literally was using Babel and WebAssembly with a specific compiler language called Walt, without ever having to touch anything. Just ran it in production. Nothing but like running Webpack in the command line. And so that's, whoa, have you guys seen this before? Does this look familiar? We don't have scope in Webpack, but who has ever wrestled with the Commons chunk plugin? It's gone. Say goodbye to it. The Commons chunk plugin is no more in Webpack 4. We completely redid the chunk graph. And so I don't have the APIs listed because I have it linked and there's a whole bunch of different possibilities. But the point is that for our production environment and for the development environment, we're setting 80% of the cases for common caching and long-term vendor hashing for you, especially for asynchronous bundles. And this is all powered by the newest feature we call mode. So now, obviously, if you don't care about the configuration, it may not be as important, but we have two specific modes now. You're either going to be running in your production environment, in which we make the code the smallest, or the development environment, which allows it to be the fastest for you. And how the hell did we make that possible in 6 months? What? Because this is what we all just did in 6 months for, from 3 to 4. So, really to sum it up, it was two things that I want to talk about that were really important to the architecture of Webpack. One of the biggest flaws of Webpack that we tend to own is that everything used to be treated as a JavaScript module. So when you used a loader and you imported CSS, it was treated as JavaScript. It had no runtime for CSS. But what we've done now to add WebAssembly support is we've implemented an architecture that's generic, and now we can say, well, here's a WebAssembly module that has its own runtime that can perform scope hoisting and code splitting. You can code split and scope hoist WebAssembly, and we're going to do it. But on top of that, now we can add HTML modules. We can add CSS modules the right way. This means you can lazy load CSS and get real bundles and have HTML files as an entry point. Everything that you would expect, because they're now going to be first-class citizens in Webpack. And then we also had the opportunity to rip out a bunch of code because of this new re-architecture. And then finally, we dropped Node v4. So now Webpack does not have to be limited by any of the ES5 syntax that wasn't allowed, or any of the ES6 syntax that we couldn't have in Node 4. So all new optimized buffers, in addition to things like maps and sets, but also weak maps and weak sets, and a bunch of other data structures that we've been able to create. And it's super optimized for V8. We saw case studies where when we upgraded, most projects that upgraded from V6 to V8 node saw 50% increase in their build times, or decrease in their build times. And then, like I said, WebAssembly support. What does this mean to me, Sean? I'm writing Angular. Well, if you understand what WebAssembly is, well, who here writes Java also? Who here also writes .NET? Who here also writes Rust? Yeah, man. That's my language. Okay. See, if you like Rust, you're going to like this. You're going to like Walt. I recommend Walt, too, for you to read. But so what if you could compile all your server-side rendered code like that into JavaScript? What if it could just, maybe not even JavaScript, but something that could run on the browser? Well, that's what the promise of WebAssembly is. But we want to put it in the hands of everybody. So here's an example of a new language that was created that looks and feels like this, looks and feels like TypeScript. But because it has static typing, it can actually compile down into WebAssembly. And because of the support that we've added in Webpack, you can use it just like a JavaScript module. But it's going to be, it can execute and run 100 times faster because it's not JavaScript, it's bytecode for the JavaScript engine. So what if you could write .NET code like that? Could change the web. And I mean, like, we're just scratching the surface. Like, I could spend a 3 billion hour talk talking about all the tiny details of changes. But I really just wanted to give you a whole, like, I want you to feel excited about kind of what it means for us, you know, shipping Webpack 4. And it kind of rounds back to this circle that I gave. Like, it's about reducing the barrier to entry, the build and the size of your code, but then also being able to have a modern architecture, and hopefully it's easier to contribute to as well. So, you know, my call to action to you is go out and try it. Even if you've never tried a bundler before, now is the perfect time because you can go and run it without even having to have a configuration file. So we separated our CLI out now, so all you have to do is npm install webpack at next and webpack CLI, or yarn add webpack next. But yes, go try it today. Report bugs if you find any. If anything just doesn't feel right or weird, we want to know because we can help make that and shape it for what the Webpack 4 release looks like. So thank you very much.
Thank you, Sean. I think we have a couple of minutes for questions. You want any questions?
If anybody has a question. Oh, there is a very eager person right there.
Okay.
Yeah, go run it to him. Yeah, okay, there. And then I can speak from here.
Hey, thanks for the presentation.
Of course.
I have a question. Are there any breaking changes in Webpack 4?
Yes, there are. So we have well, it's a major release. Every major release will have breaking changes in some way. So like, would you like me to list some of them off? Or like, so one, obviously a breaking change will be that we got rid of the commons chunk plugin. So, but we have an API that we rebuilt the API so it's not only easier to use, but you have to configure less if you want fine-grained control. Other breaking changes might be if you wrote a custom plugin, we moved some data types from arrays to maps and sets. And so, you know, calls like has instead of index of, things like that. But we'll have a complete migration guide when we release Webpack 4. In the same way that we published a migration guide from 1 to 2. And so you should be able to, as long as you go through the migration guide, we'll have it in a diff format so you can see exactly what, like, oh, this should change or this should change. And if you have custom plugins and you need help, we absolutely encourage you to reach out to us because we want to help with those kind of API migrations and stuff like that. But overall, like the biggest breaking changes are things like we removed like commons chunk, other plugins that are just now running by default. And I would say like we wait an entire month going from beta to our release to give where most of the breaking changes happen, which are our third-party plugins and loaders to catch up And so like we're working with the Angular team right now. Like they already have a branch stood up and running on V4 beta. And so like we know the list of blockers that they need help with, and we're already actively working on them. Yeah, no problem. Any other questions? Okay, well, oh yeah, one up here too also.
Thank you. I see a lot of work is going into Webpack to make Angular better, and I would like to know if you heard about the ABC project, Angular Bazel and Closure script. So basically they want to move from Webpack to Bazel.
Is that an official statement, or is that
not
just
official, the word on the street.
Oh, word on the street, okay. So is it, do we know if it's reliable or if it actually is fast or small?
That's what they're using internally at Google, actually.
Oh, okay, so are they using it in production internally at Google, ABC? Or are they using a custom like that uses those pieces? No, it's okay if you don't want to. Well, okay, so I'll say this. I think that the primitives are all being used at Google, but I think their architecture is significantly more different in terms of like having to support what Google's trying to do, which is also compile 56 terabytes worth of an entire source code with a single build tool. Oh, that's right. Okay, I think. But what was your question specifically? Like, do I have comments or thoughts?
Yeah, your thoughts, on this.
So my thoughts are, if you're Google or Microsoft or Facebook, you might need tools like this. And we all actually have our own tools tailored. So Microsoft has MS Build, Facebook has Buck. But these are build orchestration and not specific to focusing on compilation for web only. And so I think you're going to encounter some significant trade-offs by choosing a tool that's more generic and doesn't focus on delivering one thing, which is web applications, or only compiling with JavaScript and web assets. So, I mean, I haven't tested a running version of it yet.
Neither did I. It's just in the early stages of development.
Okay.
They want to move it from internal usage to the external open source.
So, like adding a Java dependency to everybody's project?
Yeah.
I mean, that's what it would do because they would have Bazel, right?
Yeah.
Okay. Well, I mean, I have comments about our opinions, but I mean, I think there's going to be trade-offs with whatever technology decision that you make. And I think it's really important to understand what is your architectural needs before jumping on to one or the other.
All right. Thank you.
Yeah, no problem.
Okay, I think that's all the time we have.
Oh yeah, we're all done. Thank you,
Thanks
everybody,
a lot.
so much.